The guy in the back has closed the door. I think that means I'm supposed to start. Cool. Hello, everyone. Hello. Hi. For those of you who read the pamphlet, you know why you're here. If you just happen to wander in this room, we're talking about a forensics thing that I just wrote. So this is my first time doing a conference, so I might as well do the who is this guy introductions. I'm Hayden. I look like that. I also look like this. Either one works for reference. I like to computer, newer computers too. I specifically like to security the computer. It's a lot of fun. I also like to write a lot of Golang. It's the last language we're ever going to need. It's perfect. This is not true, but it's fun. I enjoy writing it. When I'm not computering or at work, I like to be outside and away from computers because they actually suck and are making society terrible and stuff, but that's fine. They're cool too. So anyway, I like to go camping and outside. I have a cat. Looks like that. It's a fun fact about me. It's not an actual picture of my cat. I don't want to dox my cat, but you get the idea. I'm employed by Coinbase. We do Bitcoin things and Ethereum things and other digital currency things, if you haven't heard of us. Coinbase is a lot of fun. Blue wristband. Okay. And today we're talking about a forensics tool. So this is a forensics acquisition thing for live real-time response. I do detection and response at Coinbase currently. Okay, so let's keep going. So before we get too much into what's going on here, let's talk about what this is for, what you'd actually, like the situations you'd want to use a tool like Dexter. Real-time remote forensics acquisition is the name of the game. So for example, you want to collect a memory snapshot off of a specific host in production that's doing no-no things. Or maybe you want to collect Docker artifacts from all the hosts that are running this one service. Maybe there's like a malware thing going on, like there's a malware breakout, and you need to collect all of the files from employee machines that happen to have downloaded this file, something like that. Other stuff too is you can really, use your imagination from here. Hopefully, get the idea. Okay, so before I talk too much about the tool, there's a topic that I want to make sure we all can visit and address and take some time out of our day for, and that's the environment. Okay, as I said, I like to go outside a lot. So when we're talking about the environment at Coinbase, we're running EC2. And on this EC2 environment, we have a Gen 2-based minimal AMI. It's basically just enough to run Docker. So Docker. Big fans of Docker. Also, we're mostly an OS X shop. OS X is pretty cool. I don't actually develop in it, more on that later. But Macs are nice. Also, there's Windows somewhere in the corner. I don't want to talk about it. I don't want to think about it. We don't have a lot of this. I actually probably do really want to think about that because that's kind of my job to watch out for that. But yeah, so we're running lots of different stuff. And there's lots of different environments where we're going to want to put Dexter so that we can use this one single tool to do collection off of our whole environment should we need to do incident response. Cool. So let's talk about goals now. Goals look like this. I'm sorry, I'm only going to do this bit twice. I apologize. This is terrible. So what are the goals of Dexter? Well, first of all, it has to be secure. Try to make everything secure that we do at Coinbase. That's pretty important for what we do. So we want Dexter to be secure in various different scenarios. Also extensible. I want to make sure that when I give a conference talk about it, everyone's whipping out their laptop and making pull requests because they're so excited about how easy it is to use. Yeah, get some ideas. Okay, so extensibility is important as well. Okay, so concepts. What are the things that went into this idea here? Basically, it has to do with tasks and facts. So task is something that you're going to do for the forensics operation. That could be collect these files or really anything. You have this Go daemon that you can write any code in, and then tasks are just functions in Go. Most of them are collecting forensics artifacts. That's the purpose of the tool, right? And facts are scoping mechanisms for if all of these things about a host are true, then you should run these tasks. And together this forms what we call an investigation. So Dexter is the mechanism by which we issue investigations into the entire environment, and then the hosts check, hey, are these facts true about myself? If they are, okay, I'll run the tasks, and then that generates a report for the investigators. All feeling good about that so far? Cool. Great. Okay, so this is the general architecture in one slide. We've got a host. Okay, it's a host. It could be any of those operating systems, whatever. It's got a Dexter daemon running on it, so that's a process. That's the Go binary. Right? And it's running a simple loop. It's pulling S3 for these investigations. It's running the tasks that are defined in them if it's in scope. And then it's uploading the reports, which are the outputs of these investigations. Investigators are using the same exact binary, actually. They're just running it in a CLI mode. And using that CLI, they're able to issue these signed investigations and get encrypted reports back. Pretty cool. Okay, so this is all backed by S3 because all the other pub sub queuing services that we had on Amazon just were harder to use and figure out and stuff, and there's like a lot of complicated stuff around it. Something pops a queue and then it doesn't go elsewhere. So S3 is great. We can also look back in history really easy and see everything that's gone through S3, so it gives us a good audibility, and everyone knows S3. So, right? Everyone knows S3. Cool. Okay, great. So there's 3 problems in making this secure we're going to have to deal with. One, who can run the task? So who in the company is actually able to issue these investigations? Obviously, everyone who has access to S3, so that's part of it. But we need to be more secure than just that. And then who can read the reports that are generated? So we want to make sure that if we're dumping this stuff onto S3 and then S3 somehow accidentally gets opened in a way that's outside of my control, these reports aren't just open to the world, right? And then also privacy concerns. So like let's say one of the facts is investigate the laptop that has the Hayden user on it. You don't want the whole company or all the tech-savvy people to be looking at the investigations going, oh, I wonder what he did, right? So we have to solve for privacy in some way. Okay, so obviously this is a bad situation, right? If the tasks are really sensitive, the facts is everything, and then there's no signature, no validation. A terrorist with a Tor client installed could issue an investigation and steal all of our data. Image courtesy NSA. Thank you. So obviously this is where we're going to start. This is a bad place to start. Okay. So we could do something simple like add a signature. Okay. And I know what you're thinking. That clip art looks really familiar. So yes, I had that commissioned. That's a clip art of myself that I paid for. As you can tell, you can see the resemblance. It's fairly obvious. Now this would be kind of the go-to, right? You put a signature on something, you can validate who issued it. But at Coinbase, we're really concerned about consensus as a security mechanism. It's something that's super important to not only the infrastructure and security team, but just all the admin tools we have across all the teams. So what that means is we don't want a single point of failure where one internal threat or one compromised laptop can be responsible for a bad thing happening. So we build various consensus mechanisms into all sorts of stuff. So what we're looking for here is some sort of approval system. Now, tasks can be varied in the terms of sensitivity, right? You can have a task that's just report all the hosts so we know who's actually listening out there in Dexter, or we can have tasks like collect the memory snapshot, and the memory snapshot should be from the hosts that are signing the hot wallet keys. Like that would be insanely bad, right? Or insanely sensitive. So what we have here is a variable sense of consensus. So tasks are able to specify, I need this many approvers, and then an investigation's consensus requirement is just the highest level across all the tasks. So if you have 3 tasks on there, 2 of them require 1 consensus, 1 of them requires 3, the whole investigation is going to require 3. So, make sense? Yeah. Cool. Okay, now who can read results? This is important. So we have reports generated on the hosts by the daemon. Who's familiar with like the KEK deck model? Is that key encryption key, data encryption key? No? Okay, cool. This will be fun then. So what we're going to do here is we have investigators. They're identified by public keys, right, because they use their private keys to approve the investigations. And we're going to encrypt the reports back to them. So first thing, who's our recipients? That's a part of an investigation. We need to know who's actually authorized to read them. In this example here, Alice and Bob, because that's every example. Okay, so let's generate a encrypted report back to Alice. So first we generate a random data encryption key. So this is just a random AES key for Alice's report. And we encrypt the report, and we get Alice's encrypted report. Okay, but Alice needs to be able to read the encrypted report, of course. So we take Alice's public key, and we encrypt the data encryption key to give us the key encryption key. That's the KEK part of the KEK deck. And then we get Alice's decryption payload. So together, these make up Alice's report. And we do this because we can't take an arbitrarily large report and encrypt it to an RSA public key without like a lot of issues. So this is the mechanism by which now we're going to get these reports back to the investigators in an end-to-end encrypted way. This happens on the daemons that do the collection, right? And then it's not able to be read until we get to the host where this Alice is. And we can do this for each investigator who's allowed to read it, right? So a different data encryption key for Bob. So there's some separation there. Cool. So, okay, let's talk about privacy. We had this problem, right? Where if we're doing user exists username and some tech-savvy people realize they can get the keys for Amazon out of Dexter on their laptop and they can start looking at all the reports that are going around org-wide, they can start looking at usernames. So what are we going to do about that? It's not good. We're going to hash that, where the salt is the investigation ID, so it's randomly generated for each investigation. And then what we can do is something pretty simple, like for each user on my machine, if I'll hash the user, and if it equals the hash that's being requested, that's great. So in order to get around this, now you'd have to brute force, after the investigation is published, a list for each user. And that might actually not be too hard, which is an issue. So there's some concerns around this. I think this is the appropriate topical meme for this topic. I'm 25 now, so I feel like I'm kind of past my prime, especially when it comes to meme development. But I tried, so this is the idea, right? So that's the good one. Okay, this is not perfect because let's say the set that you're looking for is, say, 20 people. You can brute force that relatively fast. And if you use a hash algorithm that's slow enough that you can't, then it's going to be pretty hard for the host to actually do the verification, right? So there's an interesting problem here. All I'm trying to do is raise the bar, right? Make it a little bit harder. But there's definitely room for improvement on this. We're using Argon 2, so we can adjust the requirements for the hash difficulty with different variables and stuff. Okay, so let's go through an investigation example. What we're looking at here, I generated with Dexter. It's pretty simple. It's put up to S3 as a JSON structure. So we get our random generated ID. We get a list of tasks. So we're not sending arbitrary tasks, right? You can't just send code and have the host run it because that would just be remote code execution as a service. So instead we give task names and those are built into the binary, right? Now these all have arguments as well, which in this case is blank. The scope, that contains our facts. So the platform is a fact. The argument is Linux, and the hosts are going to check, is my platform Linux? For the user exist one, that's a private one, so we got the hash, like I was just talking about. Cool. Dexter also has the ability to kill any Docker containers that aren't Dexter and shut down the host after it's done. So we have 2 Boolean values in there for that. The issuer is the investigator, of course, who did the issuing. Comes with a signature. I took out the enormous base64 data because you don't need to see that. Approvers then will be more sets of these keys, these signatures, right, for the other investigators, currently known as approvedness. And then the recipients are the investigators who are authorized to then, get the encrypted report. So pretty straightforward, pretty minimal in terms of what's in here. Try to make it not super complicated. So that's a good idea. When other investigators approve this, what they're going to do is they're not going to change this file on S3. They're actually going to upload a new file that's the same exact thing, except it also tacks on their approver signature for the rest of the data. And in this way, we can see a history of, okay, who actually issued it. Obviously they're signed it in their name, but we can see when they posted it, what that file was, and then when other investigators came and approved it. So cool. That's what that looks like. Okay, so what can you do with Dexter right now? Well, there's 2 main things I wrote, and that's it. So there's a lot of work to do. But currently there's one task to dump the entire OS query database on a local system and include that as JSON. So that's pretty nifty. I'm not trying to reinvent the wheel here and make a bunch of forensic stuff that's new or that's like not new. It's just a re-implementation of some other tool. So as much as I can, it's good to I think it's good to rely on other things. So it takes I think there's like an OSX collector script out there that's pretty good. That should just get wrapped into Dexter. I'm not trying to reinvent that in Go, even though I'd really like writing Go. It's good to use other tools. And so for Docker, this was a little custom, but I wrote a task that will give you a diff report. So it will look at all the changes to the Docker file system between when the container was started from the image. So every added file, you'll get, okay, here's the added file. Removed files, it'll actually start up the old image, extract the original file, include that in the report. And for files that have changed, you get both in a diff. So that's pretty cool. Okay, I think we're on to... Oh, no, examples, not demos. Okay, examples. So this is a fact. This is the platform is fact. It's like what we saw in that example, right? Platform is Linux. Okay? So this is the entirety of the code you need to add that to Dexter, minus tests, which are a good idea. So you have this fact struct, right? You got the name. Oh, goodbye. You've got the description, minimum required arguments, right? So if you don't have enough arguments, the command line will fail. And then the actual function. The function here just compares the runtime Go OS value to the argument that was provided. And if any of the arguments that were provided are correct, if any of the platforms are the platform you're running on, then true. So extensible, right? We want to make it so you can just add one file to the repo, another file for the test, please. And then, yeah, there you go. That's a new fact ready to be used by Dexter. Rebuild it, and it'll show up in all the right menus. Okay, tasks. Same structure, same general idea, right? Except the collect OS query thing is really long, so I don't have enough screen to do all that. But you can see it's just a function that you plug into the struct that you pass during init, And yeah, one file. Pretty good. Okay, so now, yeah, now it's demo time. Cool. So we're going to go over in this direction. This is not Windows XP. This is Linux. But you know, this is the pinnacle of user experience, and so I want to be able to develop in an environment that feels comfortable and that feels empowering for my workflows. That I really feel like I know my way around. So, all right, we're in Windows XP. Cool. Just kidding. Like, what are we in right now? I think, yes, this is Sabayon, which is like a binary distro of Gentoo, because I like to make my life hard. It's pretty cool. All right, so let's make this full screen so that we don't have to look at XP anymore for the people who that bothers. All right, so what I'm going to do down here is I'm going to start the Dexter daemon. Dexter daemon. Boom. Okay, cool. That is started. And up here, I can do various things. So I got some auto-completion stuff I can run. I can interact with investigations. I can interact with investigators, reports. I can start the daemon. I already did that. Docs generates the docs. Bash will generate bash completion. So let's do it. Let's do a new investigation, huh? Dexter investigation. Create. Cool. ASCII art. Everyone loves ASCII art, right? Makes us feel like we're using Metasploit or something. Okay, so first thing we got to do is we got to select a task. So we got some autocomplete here. I can drop down a little menu, scroll through tasks. Let's add the OS query collect one. That's a good one. Let's add the Docker file system diff. Cool. Hey, it handles errors really well. Let's add Docker file system diff again. Oh, we can't do that because we already added it. Cool. Okay, let's ls. Yeah, that's nice. Let's like rm Docker file system diff. Cool, we removed it. Let's add Docker file system diff again. Woo! All right, errors. Very good. So that's it. So we got 2 tasks now. That feels good because that's all the tasks I have. But if we want to do help, we could look at other things, right? We could look at like, hey, how do I do this? I feel like someone's playing cool beats over there. No, maybe not. All right, let's keep going. So we're done with tasks. So we just enter a new line. Now we're on to facts. All right, so same kind of thing, right? I can scroll through facts. Well, I've got a lot more of those. If it's running a Docker image or like a substring of the Docker image is running, so let's say you're in an environment where, I don't know, all your engineering repositories start with engineering and you want to do that, right? That type of stuff. You can do the platform is one that I talked about. Let's do that. Platform is. Oh, but I need arguments, right? Because I had minimum arguments. Cool. Yeah, I tried to make it easy to use. Okay, so the platform is Linux. Now we got that one. And let's do my laptop. So user exists. Hayden. Cool. And that's redacted now. We're storing the hash so it knows, okay, I can't display that, which is kind of a problem because I'm the one who's making it, but more on that later. Okay, cool. So these are pretty good. There's other things we could add. What else do I have in here? Got some stuff for Docker. Project name. So Dexter will let you define a project name for your daemon, and that's either a file that opens up or an environment variable that it considers a project name for your host so that you could scope things in your production environment like we do at Coinbase. Okay, yeah, if it's running Docker images, platform is, we've seen all that before. Cool. Okay, so I think we're all done. Cool. Terminate the containers? Nope. Terminate the host? Nope. And then here can see. So I want to do this thing where it's like it's a command line loop where you can drop into all these things and drop out of them and preview your stuff. But Derbycon came up really fast when you're trying to open source something. Like, wow, you really don't realize how much time you don't have until you're 3 weeks away from the conference. So, whoops. This is the command line we got today. All right, so what else we got here? Which investigators can read it? Alice and Bob. All right. I could do things like disable access for Alice or re-enable it, but I only have 2, and the other person's going to have to approve it, so we're going to do both. All right, so we're done with that. Now we have a local encrypted private key, RSA. We're going to have to decrypt that. We're going to have to do a PEM decryption on that to sign it. So that's how we use the password to authorize signing the investigation, and it's uploaded. Cool. So I should be able to do, I almost type Docker because I do that all the time. Dexter investigation list. Okay, cool. So we can see it now in this pretty little table. We have an investigation ID. We've got the issuer, Bob, the task we're going to run, the scope, and then the consensus requirements. So each of these requires 1 approval. So our consensus level is 1. No one's approved it yet. So we don't have anyone in the reviewed by field. Neato. All right, so now what I'm going to do is I'm going to switch over to the other user. Let's see, I'm Bob right now. So now I'm Alice. All I did there was I just renamed the home/.dexter and then put the other one in because your entire identity is just what's in your .dexter home folder. So nothing fancy really going on there. Okay, so now I am Alice, and I want to improve this investigation. So I'm going to do Dexter investigation approve. And okay, so you know when you use Git and you don't want to type out the whole thing, so you type out the first part of the thing and then Git figures it out because it's like enough to make it not ambiguous? Got the same thing here. So I can just do F and it'll know, okay, well there's only one investigation and it starts with F. So there it is. Boop. Okay, get a little preview here. It's just a different view. Tables are fun. This one goes this way, not this way. So I can type my password as Alice. Spoiler alert, same password. It's password. And now I have a approved investigation. So let's check that out. Dexter investigation list. Cool. Consensus 1 of 1. Approved by Alice. Okay, and now the daemon, you see there's a log line there. Very cool. It picked up the investigation. It has now reaches consensus requirements. It does the tasks. It ran them. All done. We got the reports encrypted and uploaded. Woo! All right. So now let's take a look at these reports. So Dexter report list. Hi. Okay, so now we see that there is one host reported. Recipients, Alice and Bob. We got the scopes, tasks, all the same information. Cool. So what we can do now is download it from S3 and decrypt it by decrypting our local RSA key, and then decrypting the data encryption key, then decrypting the data. Lots of stuff going on there. All right. Dexter report retrieve F. Password. Cool. Okay, so that was fast because this is actually a local demo and I'm not going to S3, I'm going to my temp directory. A little hard-coded that in for this. Okay, cool. So we've downloaded it, we've decrypted it, and what we've done is we've created a new directory called Dexter report-the ID. And inside there we have every host that's reported. So if your scope contains like 20 hosts, they're all going to upload separately, but when you download the report, you're going to get it as one report that has all the hosts that were uploaded at that time. So that's nice. Okay, Sabayon.local is my host name apparently, so let's go there. Oh, I need to enter that directory. Some of the audience is like, oh, he didn't enter the directory, jeez, doesn't know what he's doing. Okay, let's go into Sabayon.local, cool, and what I see is each task has its own directory automatically. Great. Yeah. Cool. It's very easy to write these tasks and have it work this way. You don't have to do anything fancy. You just have this artifact writer thing where you can give it bytes of data and readers and file names and stuff, and Dexter will figure out where to put it in the file system. So it's just super easy for you guys to all write features. Don't forget it. Okay, let's check out the Docker file system diff. What do we have in there? We've got a container. Okay, cool. What's in there? We have added. So what's going on here is in the Docker report, basically to give it like a ch root. So in added, that's like the root directory of all the files that were added, and then there's gonna, if I modified anything, there'd be a modified directory, and that would be like a chroot into, you know, all the files that were modified and then removed. Same thing. Manifest gives us a ton of information about the container. Spoiler alert: I just started an Ubuntu container and then got a shell on it, and then made stuff. So oh, okay. Well, that's empty at the moment. Cool. Whoops. So let's go into that a bit. Docker files added. What do I have? Root, right? So /root on the actual container. .ssh. Cool. That's a directory. What do I have here? Authorized keys. So someone added a backdoor key. Sneaky, right? Yeah. Okay. So we found that. That's good. Where am I? Oh boy. Okay. Cool. So let's check out the OS query thing. I'm there right now. I had to change my PS1 variable for the demo because it's ridiculously long, and it's got like, you know, the name, my name, the host name, my whole directory, and then like a bunch of Git information. And so when I try to zoom up, it's like 3 lines and it's wrapping, and it's just a whole mess. So I can't tell what directory I'm in. I'm sorry. Okay, so let's go into OS query collect, and what do we have here is all the tables that OS query happened to be running on this host. We just kind of like did a select statement for all the tables that were available, and for each of those, took the results, put it in a JSON thing. So I don't know. Let's look at what sounds interesting. It's like Etsy. What? Magic? Okay, sure. A lot of these are empty because there's actually nothing in them. Yeah, sorry. But like, I think Etsy host has stuff, for example. Yeah, okay, cool. JSON. Neat. Everyone likes JSON. I like JSON. What else do we got? I don't know. Sudo. Ooh, okay. That's cool. Sudo results. Yeah, okay. So the root and wheel groups can sudo. Huh? Portage use? Okay. Cool. Look at that. There's things in there. Okay, that's neat. Yep. Okay, so let's get out of here. Let's get out of here. Okay, cool. There's some other functionality in here, right? So like now if I do Dexter investigation list, I still see that investigation. Eventually you're going to have a lot of investigations in S3, so you can do like in a Dexter investigation prune. There it goes. It's gone. Okay. Dexter report prune, same thing. Work in progress on making these features a little better for various reasons. Okay, so that was demo time. Cool, it actually worked. I'm pretty happy about the manifest thing. But, oh, thank you. Okay, we'll keep going. Cool, so the future. What is going on here? One, we have to make everything better. This is merely the humble beginnings of hopefully an open source project that actually is good someday. But things are a little rough and it very recently open sourced. So first of all, actually write tests. That's really good advice. There's one package in here that's tested. Again, Derbycon came up really fast. So there's a couple things in here that should be tested that aren't. I'm looking forward to everyone's pull requests where they test my code. Just kidding. I'll do that. But yeah, desperately needs some cleanup and tests and stuff. Investigators are currently embedded in the binary. I do this thing where I use this tool that takes the investigators directory and then it creates this virtual in-memory file system by embedding everything. So you can interact with it like it is a file system. Mostly just because I thought that was pretty cool. Also makes the binaries pretty portable once you build them because everything's baked in. They don't, you can make like a Docker image for Dexter that doesn't have any file system. It's just like from scratch. That's pretty neat. It's actually not really a great idea in hindsight because it makes it really annoying to revoke things. So if you need to revoke an investigator who's compromised, you actually issue an investigation that all of the Dexter daemons run that wipes that key from the daemon's internal memory file system so that it can't encrypt the reports back to it, which is like way worse than just deleting a file from S3. So, yep, that's happening. Versioning the config files. I made my config file a JSON file because why would I ever need to change the config structure ever again in the future? It's done. It's a terrible idea. I should probably go with something flexible like YAML. And version it so future upgrades of Dexter can use old config files, understand them, report things that are missing, stuff like that, like a real open source project. Argument validators is a cool idea. So the idea here is that I got a minimum number of arguments, so the command line doesn't let you make nonsense. However, there are times when the arguments should be even more specific than that, and in those situations, it makes sense to just write a function that validates are these valid arguments. And then you can run that function on the daemons as much as you can on the command line interface so that investigators don't make nonsense investigations. So yeah, there's the whole private arg thing, right? We did this thing with the hashing for the private arguments, which is kind of okay, except if Alice makes an investigation that has like user exists Hayden and then Bob tries to look at that. Bob's not going to be able to, brute force it in theory and figure out who's actually under investigation. So Bob's just going to have to trust that Alice says, no, I'm totally looking at that person's computer, not that person's computer, right? So that's not great for the actual consensus-driven trust model. So probably the obvious solution here is you just take the arguments and you encrypt them back to each investigator, so they can, when they pull down the investigation, decrypt the args and actually see what the scope truly is. And then, yeah, you should also have the hash, right, for the daemons, because the daemons aren't going to have keys like that. But that is the obvious next step there. And that JSON structure is getting more complicated. I don't like it. Okay, knowing when all the hosts have reported is important. Sorry, we're getting to like the bottom of the slide. There's a lot of things apparently that I want to change, so we're using the whole slide. Knowing when hosts have reported is important, right? So if there's, say, 100 hosts in your environment that are going to be the scope of your investigation, you're just going to kind of have to know via another channel that there are 100 hosts that are going to be in the scope of your investigation, because there's no mechanism for Dexter to, say how complete the reporting is. So some mechanism for that would be cool, but I don't have a ton of good ideas here. So come tell me about your ideas afterwards. Lastly, archiving, not pruning. So pruning is the mechanism by which you can just delete the old investigations and reports, but I think for auditability and legal compliance type of things, it would be good to have a archiving bucket. So you can clean up the CLI output when you're looking at stuff, but cleaning that up doesn't involve destroying the information. Maybe these files should be moved to another bucket that stores a history of everything Dexter's ever done in the organization forever, but keeps the command line clear. So that's something that I want to set up, but haven't had time for yet. Cool. Memory snapshotting is a great thing to do that I haven't done, and this is going to be a little difficult because when you're snapshotting all of memory, I have to encrypt the report still, right? And I'm using AES GCM right now, which doesn't like to do streaming and stuff, and it's hard and everything sucks. So I'm going to have to probably switch modes and HMAC it and stuff. And so there's some work to be done architecturally onto Dexter before I'm doing memory snapshotting. Also, it'd be cool to have some kernel module that I can load for each platform when it's asked to do a memory snapshot, so that's not just there all the time, and have Dexter responsible for that. That would be neat. Okay, and last, automation. So automation. There's a vision here. Okay, there's a vision of the future, and that vision involves detection tooling that is able to figure out, oh, hey, look, that's a new execution we've never seen before from that service, or oh, some mechanism detecting the application's behavior is throwing an alert. That's weird. Maybe there's like a 0-day Ruby eval vuln being used or something, like high signal things like, okay, we got a phishing email. We also got a new file load out of a weird directory within 5 minutes from this host. So, there's some detection platform that's watching the whole organization, and when that has an uh-oh moment, it should be kicking off automatic Dexter investigation, so that as a incident response person, I get an alert, hey, this happened and it's not good, but also here is a EC2 instance that in like 30 seconds is going to have all the data from all the relevant hosts, is preloaded with all the tools you need to get started to highlight what's interesting, stuff like that. So I think that there's a cool future here in just reducing the amount of things that I have to do for my job and incident response, and being able to have a response environment that's got all my evidence, that's got all my tools ready to go. And I think this is kind of the underlying machinery that's going to help us get there eventually. So that's cool. All right, so that's Dexter. It's open source already. I didn't want to be that guy who was going to open source it and did the talk, but said I'll publish it in a couple of days. It's ready. Oh, phones, cool. Hi, everyone. Hi. Yeah, so it's up right now. It's been up for a couple of days. Check it out. It works mostly. Hayden at Coinbase.com. That's my email at Coinbase.com. Blue wristband. If you want to talk, let's chat. HKParker.com is my personal website. That's hosted out of my living room. There's this whole ridiculous setup where my router VPNs to a VPS for a static IP, and then it reverses the traffic back in my living room. So I'm kind of concerned if everyone goes on that right now, it's going to go down. I'm actually kind of curious, so just let's try that. It should stay up. There's no reason why it should go down, but it probably will. So that's cool. We have a surprising amount of time for questions and stuff, so we can do that in here if you want, because I have the room. That's cool. Okay, let's go front to back up here. What's up?
Your example, Alice and Bob have access to the investigation.
Yes.
Alice and Bob win the lottery, they quit. Who has access to it now?
Great question. No one. No one. Yeah. That's a good thought, right? So what can we do about that? We could have, people in the company we trust more to be around long term. We could have, say, I don't know, someone who would never normally read it, like a VP of engineering or something. But yeah, a sharded private key, for example, that's stored in cold storage would be. We have the mechanism to do that, of course. So that'd be good. That's a great thought. So. No, no, that's awesome. That's actually, I mean, I'm here to get feedback from the community and get cool ideas. So like a break glass sharded key is perfect. Yeah.
So your facts are all handed together and run the machines that meet all the criteria. Is there a way to say user Hayden or user Charlie? Or do you have to create two separate investigations?
Oh, that'd be two investigations for now. You could make it more complicated, right? So you could have some sort of and or thing, and then eventually you just reinvent JavaScript. So we can go down that route. That'd be cool. I don't have enough experience doing that stuff, so let's reinvent JavaScript. Spilled water. Yeah, what could go wrong, right? Yeah, it'll be the backbone of the web for like 20 years. Yeah, so currently separate investigations. I consider that fine for now, but yeah. There isn't one right now, but good idea. Hmm. What? How do you mean? Oh, was it hard to see? Oh, whoops. Okay, I probably should have made everything bold. I thought I was doing a good job of zooming it. Who could see what was going on there? Most of the room. Okay. Yeah. What? Yeah. Oh, the colors. Yeah. Well, I got to have like a hacker kind of feel, you know. Yeah. So depending on where you live, I might be able to recommend an optometrist, but we'll chat. All right. What's up? Thank you. It's designed to look like an RFC. Yeah.
Have you looked at any prior art and similar tools like one comes to mind is like the Mozilla 1 Meg or whatever it's called? Some similar type thing?
I looked around a little bit. Specifically, I was looking for does anything already do the end-to-end encryption and consensus stuff, and I didn't see anything that had those two requirements. And since those are pretty heavy requirements in our team, we rolled our own. But I'm not, like I said, I'm not trying to reinvent the wheel. I would love to just take all the good forensics tools that you're supposed to run on the host and just wrap them up with this mechanism for getting results. This is mostly just the acquisition part of the arrangement, and then where we need to write our own custom tooling, because I'll go to some cool talk that's like, this is the newest cool forensics thing for OS X that no one's done yet. Yeah, I'll write a custom task for that. But as much as we can, yeah, I'd love to use whatever's out there.
Seems like duplicate investigations is going to be a problem since they're encrypted and not like a way to search for differences in those investigations. Is there any method in which we can differentiate? I know there's not really a case of it can be a modified JSON file. I just don't know how we're going to differentiate between two different investigations that have the same facts.
Oh, yeah, I see what you're saying, because they don't have date stamps. Yeah, that's one of the minor features I wanted to put on the things I need to make it better thing that didn't make it. Other ones would include like putting the consensus requirements directly in the struct so you don't have to edit the consensus config file. Like there's a bunch of small things like that. Yeah, you definitely want a date stamp in that JSON file for sure, right? And you need to be able to see that. And then you can do things like, Dexter to generate audit report history, whatever, and it'll give you like a tree for each investigation, what time, what everything happened at. Like there's, yeah, definitely PRs, I'm accepting PRs, otherwise I'll get to that someday. So
how do you primarily go through the reports? Do you like grab through the JSON?
yeah, that's a good tool. Yeah, so I really want to build Dexter report analyze, which would be the command that knows for each task what's the function that extracts the interesting information and parses it and stuff like that. I'd imagine for a lot of the tools, there's already going to be stuff to analyze it. But like I said in the automation section of the idea here, I want to, as quickly as I can, get the interesting information out. So totally in scope of the future vision of this project is that once these reports are pulled down, you can get information about, okay, what's interesting in here? How does this differ from what we'd expect? Parse it and give me summaries, give me brief summaries of the various parts of the system. And, from there I can decide what's interesting. Stuff like that. For sure. Yeah. For sure. So. Oh. Which keys? The reports? I could, but I want this to run everywhere, right? So I want to use the same thing on OS X and on Windows and other things. So like our OS X fleet would have access to KMS to piece of keys. If it's easier or more secure, it would be worth doing. I haven't really looked into it, to be honest, but just tell me why it's better in more detail after this. Yes. Okay. Yeah, I briefly looked into it a little bit, but I don't. So it does have like encrypted reporting option for like individual people and stuff like that, and crypto consensus, all that. What? Nice. Okay. Sweet. Well, that sounds cool. I'll look into that. Thank you. Yeah. Yeah, good question. So for the EC2 environment, we basically deploy compose configs with our system. I think there's been other public talks about how this works, but we spin up new ASGs and then deploy these configs for Docker across them. So there's a little helper in there by which I can say every part of all these deploys should also have this container on it, and then Dexter is containerized. And then in order to get access to stuff I need on the host, I volume in the Docker socket, so I can do Docker stuff. I volume in an OS query socket, things like that. So that's currently the idea. Now, eventually, I could bake it into the AMI once it's a little more stable. That would be cool. For the OS X fleet, so we're not quite there yet, so I don't really have a good answer. But there's options around like central management. Oh, sorry, performance? No. I should probably benchmark it. Go, great language, has good stuff for benchmarking, so that wouldn't be too hard to do, but I have not done it. So, yeah. Sorry, which clusters? ECS clusters. No, we don't use ECS. I don't know a ton about what sort of like interface you have to it, so I just have completely not explored that at all. Yeah, that's a good question. We use EC2 as an isolation mechanism as opposed to any sort of managed container solution because we don't trust containers as a security isolation mechanism just to be super paranoid. So you'd have to get a container breakout, and then you'd also have to get Amazon hypervisor breakout, which is a pretty small group of threat actors. So for that reason, we're just not looking at those things at the moment. But maybe someday containers will be really secure. So. Yeah, so the way it's configured, you can either put it in the config file that's embedded into Dexter, or it can be overridden with an environment variable. So it's global, yeah. And currently we're only doing this in places where we have the ability to distribute Amazon keys easily and ephemerally and stuff like that. When this goes out on the OS X fleet, we're going to have to talk about what that looks like, if there's some sort of like network ACL that you can do that. I'm imagining probably different S3 buckets for different scopes of the network. Just kind of coming up with that right now. I don't know. We'll see. Yeah.
Have you thought about building in some sort of archiving so if something goes down, that it failed or it didn't compromise possibility, anything like that?
Yeah, definitely. That was suggested to me before, like just before Derbycon. I thought that's a great idea, but it's not written. But yeah, I think a good task would be just report your host name. And then that way you could say, no scope, report your host name, and I can get an idea manually there. But a heartbeat would also make sense too. That would also do a good job of letting me know what's in scope, how many things I can expect. A little heavy on the traffic side, right, depending on how that's set up. So not sure what that would look like. Also, shout out and thank you to the entire rest of the Coinbase security team for all of the great ideas you've given me along the way of development. All right. Other questions? No. Cool. Well, thank you everyone for being here and letting me talk about this thing. And for the